10.4 notes, polar coordinates graphs, page 8. So here, example 10, we are graphing rose curves. And these are the curves that result in petals. Actually looks probably more like a daisy than a rose, but it's okay, still called a rose curve. So we've got equations of the form r equals a sine n theta and r equals a cosine n theta. Again, a cannot be 0 because then r would just be 0. And that would be boring. So here's what we're going to do. We've got to deal with the fact that we've got this 4 theta. So I do want to start by finding the zeros. And that's going to be, right, wherever 3 cosine 4 theta is 0. So wherever cosine 4 theta is 0. And so I'm going to look at it this way. Cosine u equals 0 at u is what? Pi over 2. Straight up and down, 3 pi over 2. So if 4 theta is pi over 2, I get a 0 at pi over 8. Awesome. That's not something we usually use. So I got 0 pi over 8. And let's take a look at the other one. 4 theta equals 3 pi over 2. Gives us that theta equals 3 pi over 8. So 3 pi over 8 is a little less than 4 pi. 4 pi over 8, which would be pi over 2. I haven't even made it a quarter way around the circle. I already have 2 zeros. So let's see if we can try to find the largest it's going to be. So the maximum value for cosine is 1. So if cosine u equals 1, that happens where? At u equals 0, 2 pi. So 4 theta equals 0, theta equals 0. So that's easy. It's 3 when theta is 0. And if 4 theta equals 2 pi, theta equals 2 pi over 4, which is pi over 2. And so I've got 3 pi over 2. First things first, I don't even have pi over 8 on here, but that's half of pi over 4. Okay, so 0. Awesome. 0 at 3 pi over 8. More awesome. And what have we got? 3 at 0. 1, 2, 3. And somehow, by the time we get to pi over 8, I'm at 0. And then at 3 pi over 8, I'm at 0, but at pi over 2, I'm at 3. So not incredibly useful here to see what this would look like. And I'm going to stop it right there because the amount of work that it would take for us to generate this curve is not anything that you guys should have to sit here and watch. So you'll notice I have a copy of this down here that we are going to just slide up here and cover. There we go. The one thing that you want to notice is here, if our n is even, so here our n is 4, the curve has 2 times that many petals, so 2n petals, so 8 petals, and we can count 1, 2, 3, 4, 5, 6, 7. We've got 8 petals. That works there. Okay, so yeah. This bottom one, r equals 2 sine 5 theta. We've got an odd n. So we have 5 petals. Notice that that multiplier out front, that 2, that tells us how far out our petals go. You guys, this is really interesting to watch on your graphing calculator. If you grab your TI-84 and graph this, it will sketch through it. Unfortunately, if you're using something like Desmo, it just plops the whole graph there in front of you, and you don't really see how that graph is created, how it is drawn as you move across or around the unit circle as the angles get larger. So that is it for roses. Like I said, you are not going to be asked to graph them. Please make sure that you recognize what you've got going on here. Notice that our cosine graph is symmetric across the line theta equals pi over 2, as well as the polar axis and the pole. Our sine graph below is symmetric across that line theta equals pi over 2, but not across the polar axis or the pole.